Let's take some time now to look at the different ways that data can be represented in various graphs. First is the most common is bar graphs. The size of the bars are related to the size of the quantities. The more that we have of that quantity, the taller the bar or longer the bar will be that represents it. These are used when we have very discrete categories that we can count, such as brands of cereal, languages spoken, or something about any particular town or city. So we want to be able to read the information that is in these various graphs. And there's a lot of different information that can be gleaned. So you don't necessarily have to be able to identify everything that the graph tells you, but be able to look for common trends and patterns. For example, if we take some time to look at the first graph that compares cereal brands and the grams of sugar per 100 grams of cereal. We can see here that cereals C and D have a higher content of sugar per 100 grams, so these are going to be some sweeter cereals. Now, we can also compare how much sweeter they are. If we look at the two less sweet cereals that have about 10 grams of sugar per 100 grams of cereal, and then we look at the more sweet cereal, we see that they are about 3.5 times more sweet. So that's just some of the information that we can get from this graph. Next, let's look at the number of students and the languages spoken. And so here we can see that Spanish dominates as the most commonly spoken language, while Latin is the least common. We also see that more than probably about 75% of our students know or speak either Spanish or Mandarin, while a very small portion know French or Latin. And so, again, we can make comparisons about the size of multiple quantities combined or individually. We can see that Mandarin is spoken about twice as much as French, and the number of students that speak Spanish is probably about 5 or 6 times as much as those that speak Latin. Last, we can look at the number of sunny days in 2019 for these 4 cities. And again, we can compare the size of the bars, but we can also make direct comparisons, such that in Rayton compared to Sunnydale, there's 100 more days of sun. Sunnydale compared to Lumi, it's only 50 days of more sun. Or we can compare Rayton to Dustville. We can compare any 2 cities and look at the relative differences in their heights and how many more days of sun they have. Another way that we represent data is through a dot plot. We can represent the frequency in which particular values occur. Normally, dot plots are best used for low, easily countable frequencies because it's often impractical to draw or even count that many dots. The benefit of dot plots, though, is it shows distributions really well. We can think of distributions as clusters or groupings of data points. When we look at this graph showing travel time to school, we see a couple different groupings. We have groupings of students that live close to school, and we have groupings of students that live far away from school. We see that a lot of students that live close to school live within 10 minutes. But those that live further away from school, there's a larger spread in their times and how long it takes to travel. And so we have these 2 clusters of different parts of our data set. A type of bar graph is called a histogram, and it uses bars to represent frequency at which ranges of values occur. It's often impractical to list every possible value independently in a bar graph if we have a lot of independent values. So we can group these values into classes. We group values, classes, where we include a range of values and then count all the data values that fall within that range. So here we have sizes of apartments. And we see that we have these range values of 30 to 40, 40 to 50, 50 to 60, these groupings of data values. Now the downside of histograms is I don't know how many values are at specific areas. So for example, if I wanted to know how many apartments had an area of 35 square meters, I don't know how many there are because I don't know what the specific values are within the cell. I just know that there are 6 data values, 6 apartments that have an area in the 30s of square meters. So here, though, we can still see a nice distribution and trend that the larger the apartments get, the fewer we have of them, except for the 30 to 40 and the 60 to 70. So this may indicate something like 2-bedroom apartments versus 3 or 4-bedroom apartments being more common based on family structure. So we may have small family homes that have only 2 bedrooms, or we have larger family homes that may have 4 bedrooms or 3 bedrooms. Another common way to display data is through a line graph, also known as a time series chart. And it shows how quantities change over time. So again, we're looking at patterns and any information over a period of time instead of at discrete specific values. And so here we can look at voter turnout for a U.S. presidential election. And we can see that over time, it's generally increasing. We see this general kind of curve shape going, and so voter turnout is going up over time. But also we see that we had this weird year, this weird voting cycle, where the amount of time or the amount of voters was drastically more than what was expected or predicted, and then it dropped down to a more reasonable increase. We also see that the increase is generally getting more and more within each cycle, and the rate of change is increasing. When we compare it to the school district enrollment, we again see a general trend of increasing. It's going up. But what's happening is we have a sharper increase in the beginning, and then the rate of change starts to level out again towards the end. So it's noticing these patterns within rate of change and the time series data that can be really helpful. Now let's answer some more specific questions. Here we have a bar graph that shows the number of women in the 101st to the 105th U.S. Congress. The number of women in the Congress saw the greatest increase between which 2 Congresses. So here we look to see where's the greatest gap from year to year. So we have a short gap here of a few, and then we have a much bigger gap, and then a smaller gap. So we know that this is the biggest time period with an increase, which was between the 102nd and 103rd Congresses. Paulina bought a video game in 2014. The line graph above shows, or below, shows the total number of video games she's owned since then. According to the graph, the number of video games she owned in 2015 is what fraction of the number she owned in 2019. So we know our graph starts at 2014, since it's years since 2014. So we're looking at 1 year later as well as 5 years later. 1 year later, she had 5 video games, and then 5 years later, she had 15. So the ratio or the fraction of her 2015 to 2019 games is going to be 1/3. The Iberian lynx population in a national park declined 2 years in a row before increasing slightly. Which of the following graphs represents the situation? Well, we look at our first graph and we have a decline, and a decline 3 years in a row. So it's not that one. Here we have an increase, and a decline. It's not that one. Here we have a decline, and an increase. That matches. And here we have an increase, and an increase. We know that one's not going to work. So C is the graph that matches.